how are before I start off with just graphing linear equations, okay, equations. What's going to be different now is we're going to be graphing inequalities, okay. So inequalities, the only difference is that now we're going to use less than, greater than, as well as less than or equal to, or greater than or equal to, instead of that equal sign. Okay, like we're not dealing with equal signs anymore. And it will require shading. Okay, we're going to have to shade areas on our graph, either above or below the line. An inequality does not only deal with the points located on the line, right? So inequality deals with points that are either above or below the line. That's important. That's how an inequality is different. We indicate this by shading, right? So we'll be shading above or below what we call the boundary lines. So those lines that we were graphing, those equations, those are going to be our boundary lines. And so we'll look at that as well. The inequality. So for example, the inequality negative 2x plus 4y is less than 16 would have a boundary line. Watch this. Would have a boundary line of this. So we take this whole inequality. We for a moment remove the equal sign. The inequality symbol and replace an equal sign into it. And the line that results from this equation is what we call the boundary line. Okay? So we're going to have to either shade above or below that boundary line. It will be splitting the coordinate plane into planes. Okay? So maybe that's important to highlight. We'll be splitting the coordinate plane into two planes, two panels, two regions. Okay? Maybe I should say that regions. Okay. Shading. In this unit, we will shade using regular or reverse shading. And how is that? How are they different? Okay. So when we do regular shading, we shade the true region. Okay. So regular shading, we shade the true region. So if you have your boundary line, so let's just make a boundary line here. It doesn't matter really where it goes, but if we were to put it right about there, just make a line. So you determine, right, that the boundary line is here. And so let's say that in this particular case, the true region is above the line. And I want to make a copy of this. We're gonna pretend like we're talking about the exact same inequality side by side. So how I copy is I just take that like that and just transfer it over. Try to make it look exactly the same. And here's something that I really want to emphasize today. If the true region is above the boundary line, it stays there. It doesn't all of a sudden flip-flop, right? Like if you determine the true region is above, then the true region stays above, regardless of which shading method you use. Okay? And I also want you to know that if you find out that this is the true region, then below the line is the false region automatically. But I'm going to always focus in on finding the true region first. Okay, that is my focus. But once you know where the true region is, then obviously the other side, the other pane, right? Because remember, the boundary line divides it into panes. One is true, one is false. Okay, so if you use regular shading, we would be shading the true region. So in this case, you're like, okay, this is the true region. I usually grab my ruler like this, and then I just start shading lightly like this. You don't have to shade it. You don't have to make it too dark because then it's harder to erase if you make a mistake, okay? Just a light shading like that, that indicates that everything above that line is true. It's a little light on the camera there, so I'm just gonna. The truth is that sometimes we're gonna have points on there and some labeling, and I don't want that to be like shaded over. I still want you to be able to see what you wrote down, okay? So regular shading, we shade the true region. You got that? Reverse shading, we shade the false region. So I go with my ruler there, and I shade the pane that's below the line. And to be honest, this is the later on when we do many inequalities, so when we do a system of inequalities, I'm gonna go with the reverse shading. Okay, that's gonna be my go-to. And I think I will explain why later on, okay? So maybe I'll just take a moment to highlight. So regular shading, we shade the true region. Reverse shading, we shade the false region. However, I think it's important to the textbook, if you ever use the textbook, only uses regular shading. But remember that the true region does not change. Only what we shade will change. Let's go down a bit more. Dash versus solid boundary lines. Okay. So if you have less than or greater than, you always read it from left to right. Less than or greater than symbols will be a dashed line. Okay. These two symbols give you a dashed line, which means that points that are on the line are not included in the solution. Okay. Points on the line are not included in the solution if it's a dashed line. So let's just make it go up in this case. So a dashed line is still saying, hey, this is the boundary. We always need a boundary line. Okay? But it's saying if it's dashed, we cannot include the points that are actually on the line. So let's say that we determine that as a boundary line, and we determine that the true region lies underneath. And so I'm going to decide to shade the true region in this case. Okay. So here we go. What kind of shading am I using if I shade the true region? It's regular. So here, maybe I'll just make something up here. So let's say this point right here is 2, 3. We would say that this is not a solution, not a solution. Because it's right on the line. So, but let's say here, I'm just making this up, right? Let's say 2, 2. This is 2, 2. And you can obviously see that that point is inside the true region is a solution. Let's make a copy of that one, okay? So try your best. You bring your ruler or whatever you have over here, and I'll just try to mimic that line. However, Now we're going to go with a solid line. So the boundary line is solid. And we still have this as true here. And we will shade that region. There we go. So let's say this is 2, 3. Because the line is solid, we would say is a solution. And so is the point that would be right underneath it, which we call 2, 2, also a solution. And I'm going to highlight, right, what's the difference between these two scenarios? In this case, we had the equal sign underneath. See how it's less than or equal to, greater than or equal to? The equal to tells you that the line itself is also included. The boundary line is also included, right? So it'll be a solid line, and points that are on the line are included in the solution region. So I think, just so you know, I'm introducing some of the topics before I actually do and graph inequalities, because all these things, these nuances are going to come in, and I just want you to have seen it, and then that way we can just move forward, okay? So some of these things will come back again and again, and you're going to, after a while, just be like, yeah, I know exactly what we're doing here, right? Because you've seen it before, we've talked about it before. All right, let's go to page 18. Rules. Some of the rules on working with inequalities. And this deserves highlighting, okay? Because it happens quite often. When multiplying or dividing by a negative, we flip the symbol. Okay? We flip the symbol. So for example, let's first ask the question. 2 is less than 5, correct? Like if you look at this statement, 2 is less than 5 would be true, right? Nobody would disagree with that. But let's say you divide both of these, so you can perform the same operations as if you would with an equation. So if you divide both by -1, okay, so if you divide both by -1, you end up with, I'm going to grab my pencil here, 2 divided by -1 is -2, and 5 divided by -1 is -5. If you were to keep the symbol exactly the same, facing the same way as before, is this statement true or false? This would be false, right? -5 is actually smaller than -2. So this is false. Flip symbol, right? So we got to go -2 is, I'm going to use a red pen maybe to emphasize. So I flipped the original the other way for that to be true. So you must do that moving forward. You can say now true. Okay, I'm gonna highlight flipping the symbol again, just so you know, you understand that that is true. And I'm gonna add something to this part here, so you can just see how that will be applicable. So let's go with an example here. let's say you get negative 3x minus 2y is greater than or equal to 10. This is an inequality, ladies and gentlemen. It's just using variables, okay? But it's an inequality because of that symbol. Let's try to isolate y as we did before. So the 3x will come over the inequality symbol positive, right? When it comes over the inequality symbol, it turns positive just like before. So negative 2y, you put the inequality symbol, comes over positive 3x, and the 10 is already there, so it's just plus 10. And in this case, we would want to divide by negative 2, right? Because you want to isolate y. So you would divide by negative 2, divide by negative 2. And you should right away, okay, you should right away be like, wait a minute, I'm dividing by a negative, correct? So before you even do anything, I would go here, maybe I'll use red to emphasize, and I will flip it the other way. Because Mr. Dirksen has shown me an example once that as soon as I divide by negative, or multiply by negative for that matter, I'm going to have to flip the sign, so flip. Okay. Flip the sign because I'm dividing by negative. If you didn't divide by negative, don't worry about it. Keep this inequality the way it was before. So this turns into just y, and this would be negative 3 over 2x minus 5. Okay. And so the emphasis is on flipping the inequality. And if you're scratching your head right now, it's okay. We'll do more of these. I just wanted to apply what we've learned here. So this was just a basic example, just showing you, hey, when you divide by negative, you have to flip the inequality, or else the statement turns false. You don't want that, okay? You want it to be accurate and stay true. Okay, next. I'm gonna, let me just think a little bit about here. I'm looking at my original notes. And I think I'm going to change this a little bit. Okay. So determine the true region or pane, test points, and shortcut. I'm just going to go with a shortcut for now. And I'm going to do the test point later. They work exactly the same way. I'm just going to stick with a shortcut. So I'm just going to highlight that one right now. The graph of the inequality, negative 2x plus 4y is less than 16, is given below. Right? I use Desmos to do this, by the way. I just type this in and it gives me that. Is this an example of regular or reverse shading? How would you know? And here's the kick. Here's the, we have to find, right? Answer, find true region. That's basically what we need to do. We need to find out which one of these two sides here of this is the boundary line. Remember that. How about we do that? We'll just extend it a bit and introduce arrows. Right? This is the boundary line. And we want to know, is this the true region or is this the true region? Like, which one of these two is the true region? That's what our goal is. So this is what I'm going to tell you every time. Isolate y. That is your goal. That is what you want to do. Okay. So let's write this out again. I like to write it out one more time. Negative 2x plus 4y is less than 16. So the 2x negative will come over the inequality symbol adding, right? So it's 4y less than 2x plus 16. Do I have to flip the sign because the 2x negative came over? That doesn't matter. Bringing stuff over, it's as if you're adding, or in this case, you're adding 2x to both sides, right, to get rid of that 2x. That doesn't change anything. Just continue as usual. It's when you divide by a negative where the inequality flips. In this case, we need to divide by 4. Is the inequality going to flip? It's not going to flip because I'm not dividing by a negative. So it just stays the way it is. 2 divided by 4, you know what? You can reduce it if you want, but you don't have to. It's 1/2, right? And I'll tell you this. Y less than indicates that the true region is below. I'm going to go capital, all caps here. Y is less than indicates that the true region is below the line. Okay. I'm going to highlight that. True is below. Those are like Y is less than tells us the true region is below the line. So we go and to our graph and we say, hey, this is the line, this is the true region. This is true, so write nice and big, true, right here. And since the true region has been shaded, what kind of shading have I used? You remember? Go one page back. If you shade the true region, I'm using regular shading. Okay. So regular shading has been used. Okay. So on the other side, on the other hand, if this pane had been shaded, which is our false region, reverse shading would have been used. So I'm going to give you the shortcut. I'm going to give you this little table here to determine where to shade. The key is to always have it in an isolated form. So you could have y is less than or equal to, y is greater than or equal to, right? So this is when y is isolated, but you also have x when x is isolated. This is usually a vertical line. Okay, so I will maybe make a note after that. So true region, when y is less than or equal to, you say below the line. So my shortcut is true is below. Okay. And if it's y is greater than or equal to, it's above. We shade the true region is above. So true is above. This is the shortcut I'm going to use when I'm gathering my information and I want to know where to put the true region. I will use this. When x is less than or equal to, less than, it would be to the left. So true region is to the left. And if it's x greater than or equal to, you would say right. The true region is found to the right of the line. So I will give you a little graph. This is just sketching it, okay? So you don't have to make it too fancy. Okay, this would be kind of like what you would include in your study sheet. So if you had a line like this, right? But you isolate and you end up with y is less than or equal to, then the true region would be here, true. If you have y is greater than, remember, just sketching, nothing fancy here, okay? And we'll just make it, I'm purposely going to go between dashed and solid because that's going to vary depending on the symbol. In this case, the true region is above the line. And some students have a hard time finding out where's above, where's below. I don't know, I just tell them, like, imagine this line, right? There's an above the line and a below the line, right? Regardless of where it's pointing, there's above, like going up, like above it, and there's below it, right? So maybe that's all I can help you with there. So let's do these two as well. So let's say you have a dashed line going here. You end up with a vertical because remember, it's just x, right? X is the only thing that's left. And here you would say, hey, the true region is to the left of the line. And then one more. Where let's say our vertical line is right here. And the true, because x is greater than or equal to, is over here. I'm just gonna quickly mention something here. The y here could also be a horizontal line if you end up with just a number on the right side, but it would still work the same way, right? It would either be below or above, depending on your symbol. Okay, so the symbols tell us where the true region is. That's what I want you to focus on. The shading will come later on. Okay, so let's keep going. Let's apply what we've learned here so far. And you will see that there's a lot of overlap with what we've been doing already with graphing linear equations. Okay, so graphing inequalities. So determine the intercepts, rewrite the inequality, so rearrange it in this form. A graph using regular shading. So for now, we're just going to use regular shading, okay, to get us started. Okay, let's find the intercepts first and foremost. So I'm going to go intercepts. This is on page 19. I'm going to zoom in to that region a bit so that we're not graphing just yet, right? So there we go. And to be honest, I don't like it this way. I like my constant to already be on the right side. So let's do a little rewriting already. 4x minus 5y. I'm going to put the inequality down, and this negative 10 comes over to the other side. It comes over as positive 10, like that. I like it this way. Okay, standard form. So intercepts, I go x-intercept, y-intercept. My boundary line, okay, I'm going to use this. I'm going to write this down. Boundary line is the exact same inequality that I already started with, but it's going to look like this. 4x minus 5y is equal to 10. Okay. I just want to tell you something. The boundary line is just used here to find the intercepts. Then we go back to inequalities. Okay. So you're seeing this, right? The only difference is that I got rid of the inequality. I'm like, okay, let's focus on that line that's going to cut my coordinate plane into two planes. So the intercepts would be 4x is equal to 10, correct? Because the y is equal to 0 when you're finding the x-intercept. Divide both sides by 4. X is equal to, in this case, it's 2.5. So the x-intercept is 2.50. I prefer you writing it as a coordinate just to make sure we're not mixing it up with an equation. Y-intercept, x is equal to 0. So it's 4 times 0. So you end up with negative 5y is equal to 10. I have to divide both sides by negative 5. Y is equal to negative 2. Negative 2 it is, right? Because we're going 10 divided by negative 5. And this is where practice, so after you see me do this, you're like, I got this, right? It's those little things that you need to practice to make sure you don't make any sign errors or anything like that, okay? So these are my intercepts. Perfect. It's asking me to rewrite the inequality. And I want to make sure I'm going to circle this and I'm going to say, hey, I used the boundary line to come up with the inequality. I'm going to be honest with you. I don't do this anymore. Later on, I just imagine this is my equation here and I just use that one. You don't have to write this down anymore. I'm just letting you know this is what I use to come up with my intercepts. So now we have a line going. Okay? So let's rewrite. So I'm referring to this one here. We'll rewrite. Should I write this? I'll be more specific. Rewrite the inequality. Okay, IQ. Why am I doing this part here, the rewriting? Because it will tell me where the true region is. Okay, so you're still fresh. It's your first day back, right? So maybe I should say rewrite the inequality in brackets to find true region. Okay. That is why I'm doing this part. Also because then I can enter it from my calculator. But our main reason is to find a true region. Okay. So the 4x will come over to the other side. So we end up with negative 5y is greater than negative 4x plus 10. Okay, got that part. No flipping a sign here. Okay. Then I will divide everything by negative 5 in order to isolate y, because remember that's my ultimate goal. And that should give you an alert right there. Flip inequality symbol. Because I'm dividing by negative. Okay. So I'm gonna, this pointing right, it's gonna be pointing the other way now. Because I'm dividing by negative to keep this true. So that ends up with y. Negative divided by negative is just positive, right? So it's 4 over 5x. 10 divided by negative 5 is negative 2. And here's where I bring it all together. I highly encourage you to do this, okay? What's the order that I'm doing this? Okay, yeah. So is this solid or dashed line based on this symbol? You got to go back and what you've learned. There's no equal sign, so it's going to be a dashed line actually. The line itself is not included. So I'm going to go dash And then I'm going to say true is, if it's y is less than, where's the true region? I actually want you to use your notes for this one, because I'm going to go back here. Which one of these two am I dealing with? I'm dealing with y is less than, right? So the true region is below the line. I'm going to go back. After a while, you're going to be champs, right? True is below. Oh, sorry. So I'm going to say shade below, because I'm shading where the true region is. So why? Why are you shading where the true region is? Because we're using regular shading. Okay, that's why. You shade where the true region is. Okay, so I will be even more specific. Regular shading. But this is how this is a bit, to be honest, too much work. So you will see me in the future saying dashed or solid. So D or S, and I'm going to say true is below, and I'm going to say comma shade below. I'm saying the exact same thing as up here, just in code wording there. Dashed, true is below, shade below. Okay, so now you know what I mean with these three letters there. So let's go ahead and do that. Let's go to our grid. And after this, you're going to try some on your own. 2.50, 2.50 would be right there. And then 0, -2 is right there. And make sure you use a pencil for these ones, okay? So it's a dashed line, I'm told. So that boundary line, and you just go like this, right? Dashed. And that's an easy fix if you forget to dash. You just use an eraser later on and just erase a few sections along the way. And there's your arrows, and I'm going to put down I'm going to write down the inequality. You choose which one. I really don't care, as long as you label it. So dashed, true, I want you to label it. It's very important to me. So true is going to be below here, below the line. And the last step is shading. We're going to shade below the line, because we are saying that all the points that are below this line are true. We'll make this inequality true. So grab your ruler. And here's what I'm talking about. So you have I have the equation, I have all of that stuff. You can shade over it. Just make sure you're like basically shading so much that I can't see what's behind it. Come on, pencil. Cooperate. There. To be honest, the most important thing about like whether you're going to shade regular or reverse is you telling me where the true region is. The true region does not change. It doesn't change. Once you determine it's below, it stays below. We may shade reverse where we shade out our false region, but the true region stays where it is. So let's write down false. There's nothing wrong with saying, hey, this is false, but I tend to focus on the true region. Okay, so a couple of things just to recap here. So if I ever ask you, hey, give me one example, one point that is a solution to this inequality, you just go anywhere in the true region, anywhere. So you could go 10, right? So x10, y is -5. This would be a solution here. 10, -5, a solution. Right. Mr. Anderson, could I pick 9.99, negative 4.99? Sure. It's anything that's in this solution region will do the trick. I'm lazy, I'll just take the easier one, right? If you can relate. But in this particular case, 2.50, is it a solution? Can I pick the one that's right on the line? I cannot. Two reasons, two things that could give it away. It's a dashed line, or just go by the symbol, right? There's no equal sign. So the equal tells you, oh, the line is part of it, right? If there had been like an equal sign underneath this, then yes, okay, not a solution. So is 0, -2. It's also not a solution, right? So anything on the line is a no-no in this case. But anything in the true region, for sure, okay? But sometimes we want to know, do you really know your stuff? Do you really know your stuff? And here's where we test that. So, for example, is 40/30. Can you just do an exercise with me here? Pretend like you don't see the graph right now. Can you pretend the graph isn't there? Okay. 40/30, is it part of the solution? Is it a solution to this system? And here's where your algebra skills are going to come in handy. Let's just plug in and go. Okay. You're listening, right? You take this point and you plug it into any inequality that appears on this paper. You can use the original. You can use this one. You can even use this one here if you want, but I tend to use the original just in case I made a mistake on the other ones. So let's plug in the 40/30 into this inequality. Okay. So you're writing this down. I'm almost done, guys. Plug in into OG. I'm using that with my kids right now. They're making fun of me. Do you use that as well? It's the OG of whatever, the original. Into the original inequality. Maybe that'll confuse you, but into the original inequality. So we're going to go like this. 4x minus 5y minus 10 is greater than 0. Okay, and then wherever there's an x, you're going to plug in 40. You got to be careful. Sometimes I flip that on you on the inequality. I have them in a different order. So you're just going to make sure the 40 goes in for x minus 5y minus 10 is greater than 0. 4 times 40 is 160. 5 times 30 is 150. Minus 10 is greater than 0. What do you think this is going to amount to? It's going to be 0, right? Is 0 greater than 0? No, they're equal, right? So, false. So the state, when you plugged in, it's false, right? Therefore, it is not a solution. Students overthink a question like this quite often, and they just, I'm just going to leave it blank. I'm just going to move on. It's like, really, just plug in and see if it works. Okay. Next. You want to try that one? Try that real quick. Plug these two into, you have the original inequality right here. Just plug in these values and see if it works. And I'll update my attendance. All right. That's your starting point. And and this ends up being negative 340, supposed to be greater than 0, and that's a definite false, not a solution. Okay. I'm just going to put in a side here a little note. If this had been, if you would have ended up with 0 is greater than or equal to 0, it looks like an emoji or something, or trying to, right? Would that have been true? If you had this, 0 is greater than or equal to 0, it is true because of the or is true. Okay. Is it greater than or equal to, right? That's what the statement is saying. So that would have been true, but because I'm only left with 0 is greater than 0, that is not true. That's a false statement, right? So a little change can make a big difference. Okay. All right. Oh man, I feel like you're done already. I want to do one more, a special case. It's not going to take long. Okay. So let's go to 20. And then you'll have some time to practice some or unwind. When you scan this, you should immediately recognize, sometimes it's not obvious at the beginning, but you should recognize that there's only one variable, correct? You see it? So it's no y variable, right? So that's something I would like you to see right off the bat. So there's no need to find, so this is a special case. No need to find intercepts. These are actually the easiest ones to do. Okay, so all I do is I combine like terms. So I go 3x. This x I'm going to bring over towards the 3x. It's going to come over subtracting, and that's less than 6. Remember, I just keep that sign the same way. That is 2x is less than 6. I divide both sides by 2. X is less than 3. Okay. This is going to be dashed. Where's the true region? True. If it's x is less than, let's go to our cheat sheet real quick here. It's one of these two, right? X is less than tells me that the true region is to the left. So true is left. Oops. Shade left. But the shortcut is dashed. True is to the left. We're gonna shade left as well. I'm soon gonna get rid of this. My answer key will not have this. It will just have this. Okay. Can I just go up to this one real quick? Vertical goes through 3 0, right? 3 0. If it's x, it goes through 3 0. So you just go over here, make a dot, use your ruler. It's going to be a dashed line. Make sure you have arrowheads. X is less than 3, like that. And then just, you know what's more important to me than, well, shading is important too, but make sure you clearly identify where the true region is. It's to the left. You've already determined that. And then just grab your ruler to act as a break there. Good enough in my books there. Is 4, 7 part of the solution? Where's 4, 7? 4 is here, 7 would be here. It's definitely not part of the solution, right? Because it's in the false region. But you could just plug it in. I'm using the original. 3 times 4 is less than 4 plus 6. So that's 12 is less than 10. That's false. Not a solution. Okay. I'm gonna ask you to just work at pages 23 to 25 for now. Obviously, if you find that it's too much, just do, every other one, but do practice going through the process. It's very important. Okay, let's get back into the game. Thank you guys. You were great.